This is Ceva's theorem. The basic idea behind it, that way you understand, is if you take the ratio of the sides. So let's say I'm starting at A, so I say AD over BD should be equal to, if I follow that same pattern, BE. Well, if I multiply that times BE over EC, and then I multiply that by CF over FA, that should all equal 1. That's Ceva's theorem. What I'm going to do is use the same thing, but I'm going to use the inspire to measure this to see if it's true. So what I did here, I kind of set it up already. I stored some values in here. I stored all of them, but all of them except for the first one, so I can show you how to do it. So I'm going over to this triangle I created, and I'm just going to right click. Ooh, there we go. And I'm going to hit store. So I clicked on it once and then right click and hit store. If you're doing this on a calculator, it's the same thing as clicking on it and press Control bar. Same thing. And I'm just going to store that. And I'm using capitals. You don't have to. But I'm storing it as AD. So now I have all these things. So I have AD, BD, BE, EC, CF, and then FA. I like going in the order that it shows up, or the direction I'm going. I have seen it where they rearrange this. They would say, no, this is AF, not FA. I just did it for aesthetics for me personally. So if I do that, and I'm gonna do a little bit of cheating here, since I have this right here. I'm gonna right click on this. I'm gonna copy it. So I press Control V. I'm gonna Control C. Now Control V. So basically, these are all the letters, and so I have them here. I just took out the equal sign to see, so that way I can calculate to see if this will work. So I right click on this, I go to calculate, and I keep pressing the letter L until a number shows up. And the number that shows up is 1. So this should be dynamic, so if I move this, it remains at 1. The numbers are changing. So it does work with Ceva's theorem on the inspire. Now this is what occurred. A student came to me with a question like this, asking how do they solve this? And I was like, oh, okay. Now they had this here. It's already stored. I just kind of made this. The question looks sort of like this, but I made this one up. And I'm just going to use what I know about Ceva's theorem to find the missing side. So if I went in a pattern, it should be AD over BD. This I don't know, so I would call it X. And then I have E over EC, so X over EC times, and this is, they said FC, so FC over AF. So now that I have that, I'm going to use the inspire to solve it to see if it works. And I'm just going to do a new page. So I'm just going to do home, and I'm going to go to a calculator page. I could go to Scratchpad, but I try to stay away from that because it's not as good. And I'm going to do menu 3-1. That's to solve. And then I'm just going to set up the fraction if I was going in a clockwise motion. So I know I had AD, it would be AD over BD times, and I didn't know the next thing, which was BE, so I'm just going to call that one X since I don't know it. And that's going to be over EC times, and then the way they label it as FC, and then the other part as AF. That's equal 1. So in here I have to, because I'm in solve mode, I have to do the variable I'm solving for, and I'm solving for X. So I just do comma X, I'm just going to close parentheses and hit enter. And it's telling me that it should be 3.40987. And it's probably rounded. So 3.41 would be the answer. So the inspire rounds a little bit, but it definitely works. Got me the answer.